In this episode, we take on a format that looks friendly right up until it breaks your automation in a way that feels unfair. YAML. It shows up everywhere in operations and cloud workflows because it is human-readable. It supports structured data, and it can express configuration in a way that feels less cluttered than formats filled with brackets and braces. The problem is that YAML's friendliness comes from relying heavily on whitespace and formatting rules that humans handle casually and computers treat as strict law. Beginners often assume that if a file looks aligned, it must be valid, and they are shocked when a tiny indentation change or an unquoted value alters meaning or causes parsing failures. When YAML is used in automation and pipelines, those small surprises can become big problems because configuration is often the starting point for decisions, and decisions drive actions. Safe YAML handling is not about memorizing every corner case, because it is about learning the common ways YAML creates unintended meaning and building habits that prevent those pitfalls. The goal is to treat YAML as a powerful tool that demands precision, much like a carefully labeled control panel, rather than as a casual note-taking format. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good place to start is understanding what YAML is doing conceptually, because that makes the formatting rules feel less arbitrary. YAML represents structured data using indentation to show nesting, and it uses simple markers to show lists and key-value pairs. That means the indentation is not decoration. It is the structure itself, and changing indentation changes the shape of the data. When the shape changes, the downstream automation may read different keys, treat a value as belonging to a different object, or fail to find a field it expects. This is why YAML problems often show up as missing fields, wrong defaults, or unexpected behavior rather than as a clear error message. YAML also supports multiple ways to write the same thing, which can be convenient, but can also make files inconsistent across teams, increasing the chance that someone edits a file without realizing how structure is being expressed. Safe YAML usage begins with a mindset that structure is the product, not the visible text itself. When you see YAML, you want to see a tree of data in your head, and that tree must stay stable when the file changes. Indentation is the most famous YAML pitfall, and it is the one that creates the most dramatic formatting surprises. YAML uses indentation to represent hierarchy, so a key that is indented under another key becomes a child of that key rather than a sibling at the same level. If you accidentally indent a block too far or not far enough, you can move entire sections to the wrong place. This is especially dangerous in automation contexts where a configuration file might define environment targets, credentials references, or policy settings, because one indentation mistake can cause a value to apply in the wrong scope. A beginner might visually scan and think it looks fine because the lines are still aligned in a general sense, but YAML requires consistent indentation depth, and mixing tabs and spaces can make files that look aligned to a human but are not aligned to a parser. Safe practice includes using consistent spacing and treating indentation as a controlled convention rather than a personal style. When you approach indentation with that respect, you reduce the chance that a small edit becomes an operational incident. Another common source of surprises is how YAML interprets values, because YAML tries to be smart about types. That means an unquoted value might be interpreted as a boolean, a number, or null rather than as a string, depending on its shape. This can create a subtle mismatch between what you intended and what the automation reads, which is a classic silent failure pattern. For example, you might intend a value to be a string identifier, but YAML might interpret it as a number, and then the consuming logic might treat it differently or fail validation unexpectedly. Even when YAML handles a value in a way that seems reasonable, it might conflict with what the downstream system expects, such as a string that must remain a string even if it looks numeric. This is why safe YAML usage includes deliberate quoting when there is any chance a value could be interpreted in more than one way. Quoting can feel like extra work, but in operations it is often cheaper than chasing a bug caused by a type surprise. When you learn to anticipate type inference, you stop being surprised by it. Keys and duplicates also matter, because YAML files often grow over time, and growth can create repeated keys or conflicting definitions. In some situations, a duplicate key might override a previous value, or it might be treated as an error, depending on the parser and the tool consuming the file. This is dangerous because two people can edit the same file and unintentionally create a configuration that looks correct in one section, but is silently overridden later. Override behavior can create drift where the configuration you think is active is not the configuration the tool is actually using. A safe approach is to keep YAML organized so that key names are unique within a given scope and so that related settings are grouped consistently. This also helps code review and troubleshooting because reviewers can spot conflicts more easily. In automation pipelines, configuration errors are often diagnosed late because the pipeline fails downstream. So reducing ambiguity in the config itself is a major risk reducer. When you treat key uniqueness as part of correctness, you prevent quiet overrides from becoming hidden landmines. Lists in YAML are another area where formatting can create confusion because lists can be expressed in ways that make it easy to misread what belongs to what. A list item is usually indicated by a dash, and the indentation of that dash determines the list's parent context. If a dash is misindented, an item might end up in the wrong list or not in a list at all, and that can change behavior significantly. Lists are commonly used for targets, rules, allowed values, and sequences of steps, which are exactly the kinds of configuration that drive automated actions. A beginner might add an item to what they believe is a list of environments and actually place it under a different key, causing the pipeline to ignore it. Another common mistake is mixing list item styles in a way that is technically valid but hard to interpret, increasing the chance that a future edit breaks structure. Safe YAML usage means treating list indentation and grouping as carefully as you treat braces in other formats. If the list structure is wrong, the automation logic that depends on it becomes wrong too. YAML also supports more advanced features like anchors and aliases, which can reduce repetition by allowing you to define a block once and reuse it. This can be helpful for consistency, especially when multiple environments share similar settings. The risk is that reuse can become confusing if readers do not realize a value is inherited from an anchor, leading to edits in the wrong place and unexpected changes across multiple sections. Even if you are not writing complex YAML, it is useful to understand that YAML can hide reuse in a way that is not obvious to beginners. Safe practice is to keep reuse mechanisms simple and to ensure that team members can easily trace where values come from. In a pipeline context, hidden inheritance can create hard-to-debug behavior when a change in one anchor affects many environments. The operator mindset is to avoid configuration cleverness that saves a few lines but increases the cost of understanding. Configuration should optimize for clarity and predictability, not for minimal file length. Another source of formatting surprises is how YAML handles strings that include special characters, colons, or leading symbols. Because YAML uses colons to separate keys and values, a value that contains a colon can be misinterpreted unless it is quoted properly. Similarly, values that begin with certain characters can be parsed in unexpected ways, especially when they look like they might indicate another structure. In operations and cloud contexts, it is common to have values like resource identifiers, URLs, timestamps, and tags that include punctuation, and those values are exactly where quoting protects you from misinterpretation. A beginner might assume the value is just text and is safe unquoted, but YAML parsers may interpret it differently depending on context. Safe YAML handling means you recognize when a value could be ambiguous and you remove ambiguity through quoting and consistent formatting. This is not paranoia. It is defensive configuration, and defensive configuration is a core theme of safe automation. When you eliminate ambiguity, you also eliminate a class of failures that only show up in specific environments or after small edits. YAML safety is also about how you maintain configuration across environments, because small differences between environment files can create big behavioral differences. If one environment file uses different indentation, different quoting conventions, or different type representations, the same automation logic might interpret values differently across environments. That inconsistency is a form of drift, and drift is dangerous because it makes behavior unpredictable and makes troubleshooting harder. A safe approach is to standardize conventions, such as using consistent indentation width, consistent quoting for ambiguous values, and consistent ordering of keys. Standardization is not just for aesthetics, because it reduces the chance that someone makes a formatting mistake and it makes differences between files easier to spot. In pipeline workflows, being able to compare configurations quickly is a real operational advantage. When you keep YAML consistent, you reduce the cognitive burden of edits and reviews, which reduces the chance of mistakes. Consistency is a risk control disguised as style. It is also important to recognize how YAML interacts with type-sensitive consumers, because YAML is often used as an input to tools that expect specific types and formats. If the consumer expects a string and YAML provides a boolean, the consumer might reject it, or it might accept it and behave differently, depending on how strict it is. If the consumer expects a list and YAML provides a single value due to formatting, the consumer might interpret it as a different structure and proceed incorrectly. This is where validation becomes critical, because you want to catch structure and type issues before they reach the action stage. In a safe automation design, configuration is validated early, and invalid configuration causes a controlled stop rather than an attempt to proceed. This connects directly to the fail-safe conditional mindset, where you refuse to act on uncertain inputs. YAML problems are often caught at runtime, which is late, so the earlier you validate, the less damage you risk. Exam questions in this area often reward answers that emphasize validation and conservative behavior when config is ambiguous. Another beginner misunderstanding is thinking YAML is just another way to write the same data as other formats, and that converting between formats is always straightforward. In reality, YAML's type inference and flexible syntax can produce subtle differences when data is converted, especially around booleans, numbers, and null values. If a pipeline converts YAML to another structured format, the resulting types might change, and that can affect downstream logic. This is why you should think about boundaries, meaning points where configuration is parsed, transformed, or handed off to another stage. At each boundary, there is an opportunity for misinterpretation, and safe design includes checks at those boundaries. You also need to be mindful that humans edit YAML directly, which makes it more prone to accidental changes than machine-generated formats. Human edits are normal and necessary, so the safety goal is to make the file robust against common editing mistakes. When you understand conversion and boundary risk, you can design workflows that detect YAML surprises before they affect production behavior. When you connect YAML handling to other core automation concepts, you can see how it fits neatly into the broader reliability story. Primitive data types matter because YAML may infer types, which affects comparisons and conditionals in your automation logic. Parameters matter because YAML often carries environment-specific values, and those values must be clear, validated, and safe by default. Functions matter because parsing and validation logic should be encapsulated so every script treats configuration consistently. Iteration matters because YAML often defines lists of targets or rules that automation must process safely without assuming perfect structure. Logs matter because when configuration issues occur, clear log signals can help you detect that the configuration was misread or that a default was applied unexpectedly. This is why YAML safety is not an isolated skill, because it touches every other part of automation behavior. When YAML is correct, the rest of your automation has a solid foundation, but when YAML is ambiguous, everything built on it becomes uncertain. As we wrap this up, the main point is that YAML is a powerful configuration format precisely because it is human-friendly, but that same friendliness comes with risks that you must manage deliberately. Indentation defines structure. Type inference can change meaning, duplicates and list formatting can create silent overrides, and special characters can introduce ambiguity if you do not quote carefully. Safe YAML use means choosing consistent formatting conventions, quoting values that could be misinterpreted, validating structure and types early, and treating configuration as a safety boundary rather than as a casual file. In cloud and pipeline contexts, where configuration can trigger changes at scale, preventing formatting surprises is not just about avoiding errors. It is about preventing unintended actions. On exam day, the best answers usually reflect this cautious approach, emphasizing explicitness, validation, and conservative behavior when config is unclear. In real operations, Those same habits reduce incidents and reduce the time you spend hunting for invisible whitespace problems. When you treat YAML with respect and discipline, it becomes a reliable tool for automation rather than a source of formatting surprises.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.